8.4, simple complex fractions. So we're going to start with a quick review. Now notice, pay attention. Wow. There we go. I know how to use the board. Pay attention to the operations. Okay. So number one is an addition problem, and number two is a multiplication problem, times. Remember the differences. When we add and subtract fractions, we must have a common denominator. For multiplication and division, we do not need a common denominator. If you spend time on a multiplication problem finding common denominator, you're just creating a bunch of work that's going to be undone in the end. So let's just get to the review. So first off, this is x over 1. So at the beginning, we need to factor this perfect square. Difference two squares. 2x plus 6 and x minus 6. Now, again, we talk about a shopping list. We're going to the store. What do I need? I need an x plus 6 and an x minus 6. Well, the first fraction has it. Does the x have it? No. What does it need? It actually needs both of them. So I need to multiply the top and bottom by x plus 6, x minus 6. Because remember, with an expression, you can only multiply by 1. So whatever you do the top, you must do the bottom, and vice versa. So this is going to take a lot of room, so I'm just going to start over here. Our first fraction stays like so. No big deal. Then, on our other fraction, we have an x on top, and we're going to multiply by x plus 6, x minus 6. And that gives us the same on the bottom. And then we're going to do minus 2x. Now we ask ourselves, what does this need? Well, the x minus 6 is here, but we need an x plus 6 on the bottom. Now we can't just do that to the top. We need to also do the same thing. Can't just do that to the bottom. We need to do it to the top also. Okay? So there's obviously not enough room, at least with my markers, to do this. So I'm going to go over here. Now there's two ways to go about this. Okay, so first off, we have 4 plus, we have our x, and then we have x squared minus 36. Now where'd that come from? That is just the x plus 6, x minus 6 multiplied. And hopefully if you realize that we factored x squared minus 36 into those two, they're going to multiply right back to being x squared minus 36. Minus 2x, and this is all over x plus 6, x minus 6. Now, I'm fine with you not writing x plus 6, x minus 6 in the denominator every time, because this is usually going to be 3 or 4 steps, and it just gets redundant writing that. It takes up a lot of space. But you have to remember to write it for the last step. Because if you do all this work and forget the denominator, it was all for naught. It's going to be a wrong answer. So you have to know whether or not you will remember that or not. If you're one that forgets it, you might need to write it every time. Oh, and I forgot the 2x times x plus 6 here. Okay, so now I'm going to write 4 plus, distribute my x, so that's x cubed minus 36x minus, I need to distribute the 2x squared plus minus 12x. Pay attention to those symbols. Minus 12x. So negative 2x times x is negative 2x squared. Negative 2x times 6 is negative 12x. Now again, you can skip this step, or you can write it if you need to. Now I'm going to join like terms. There's only one x cubed, So that's simple enough. There's only one x squared, so that's negative 2x squared. X's, I have negative 36x minus 12, which is negative 48x. So those are taken care of. And then I have plus 4. And then finally, this is where you need to write it if you haven't been writing it, all over x plus 6, x minus 6. Alright, remember, if you need to hit pause anytime because I'm going too fast, just do that. Now, for number 2, we do not need to worry about common denominator. But we still want to factor to see if we can cancel stuff and make it easier on ourselves. So over here, whoopsie. Over here, this is going to factor to x plus 3, x minus 3. And that's because it's a difference of 2 squares. X squared minus 9. And up here, I can pull a 3 out and get x plus 3. Now, we're always going to give you problems where stuff factors and then cancels. It's always going to be a possibility. So, this x minus 3 can cancel with this x minus 3. This x plus 3 can cancel with this x plus 3. So what are we left with? Well, 1 times 3 is 3. And then on the bottom, all we have left is the 4x. So really, there's really nothing to multiply. After everything cancels, we just write that. 3 over 4x. And remember, some people might write it this way, 3/4 x. Same answer. Okay? Doesn't matter. All right. How do you do the following problem? 2/5 divided by 7/10. So that's a fraction divided by a fraction. Well, a complex fraction, our new term, is a fraction that contains a fraction in its numerator, denominator, or both. So it's just a fraction with a bunch of fractions. So what we're going to do is we're going to rewrite this complex fraction as a division problem. And remember, then you're going to multiply by the reciprocal. So the first step is to take 2/5 divided by 7/10. And then we're going to change it to 2/5 times 10 over 7. And now we have two choices. We can multiply across, then reduce, or reduce first. I always like to reduce first. 5 goes into 10 twice, and that gives me 4 over 7. Now again, if I didn't do that, I would have gotten 2 times 10 is 20, over 7 times 5 is 35, and then have to reduce by 5 and get my final answer of 4/7. I find it personally easier to cancel before multiplying because it keeps the numbers smaller and more friendly. All right, here we go. So, we're going to first write it as a division problem. xy cubed over 9m divided by 4x cubed y cubed over 3. Now, I'm going to change this to multiplication, and this one is going to flip. So this one stays the same, xy cubed. You never touch this one. You don't ever flip this. You don't do any changes to this. And then this is going to be 3 over 4x cubed y cubed. Now I can begin canceling. Again, if you want to multiply straight across and then simplify, that's fine. I'm going to cancel first. So this 3 right here, get rid of that shepherd's hook. This 3 can cancel with this 9 3 times. 3 goes into 9 3 times. That's it. The 4, nothing to cancel with. Now, on top, I have 1x. On the bottom, I have x to the third. I can cancel this with one of these, leaving me x squared. Then I have y cubed on top, y cubed on the bottom. Those can all cancel with each other. Now, this gets to an interesting point. Everything on the top is canceled. Some people have a tendency to want to say, oh, that's 0. But that's not right, because if you put 0 on the top, that makes the whole fraction 0. So what is left? 1. And think about it. When 3 cancels, 3 really leaves a 1 here. Anything divided by itself is 1. So if you have a problem remembering that, you might want to make sure you put 1s when you cancel your numbers. Now, what's left on the bottom? Well, 3 times 4 is 12. I have an m left. There was nothing to cancel there. I have an x squared, and that's it. I'm finished. 1 over 12 mx squared. And again, some people might write that as 1/12. But the problem is, as opposed to this, which problem was it? I'm glad I just did this because I just caught my own mistake. I wasn't thinking. 3/4 x is not the same as 3 over 4x. 3/4 x is the same as 3x over 4. This x right here actually represents x over 1. It's on the top. So I can't do that. That's a big no-no. So sorry about that. Correct that. And when we come down here, we're going to leave this answer. We cannot rewrite that as 1/12 anything because the mx squared is in the denominator. So sorry about that, but glad I caught it. Otherwise, somebody would be telling me the next day. Number 2, going to rewrite this as a division problem first. Yeah. The fun of technology. So, x minus 3 over 5 divided by x squared minus 9 over x plus 1. Now, if I wanted to, I could have just factored that x squared minus 9 right off the bat, because I noticed the difference in 2 squares. I can do the next step. It makes no difference. So now, the next step is rewrite x minus 3 over 5. We're going to change the division to multiplication, and we're going to flip this. Now, the x plus 1 is going to come to the top, and I'm going to factor right now to x minus 3, x plus 3. All right? Now, at this point, I see what will cancel. This x minus 3 will cancel with this x minus 3. And that's pretty much it. So what's left on the top? X plus 1 over 5x plus 3. Trying to clean that up, it kind of looks like a 13. And that's it. Okay, moving on. So here we have x plus 2 over 3 divided by 3x plus 6 over 12. So I'm going to change it to multiplication. X plus 2 over 3 times, the 12 is going to come on top. I'm just going to factor the 3 out right now, x plus 2. And now the fun begins. This x plus 2 cancels here. Either one of those 3's can cancel with the 12. Since it's right underneath, I'm going to make this a 1 and make this a 4. And I'm pretty much finished. On the top, I'm left with a 4. On the bottom, all I'm left with is a 3. That actually simplifies to the fraction 4/3. All right. There we go. 15x over x plus 4 divided by 3 over x squared plus 4x. Rewrite. We'll leave this the same. X plus 4. Change it to times. The 3 is going to go to the bottom. I'm going to pull the x squared plus 4x up to the top. And I'm going to just factor the x out at the same time. Oh, and look right there. We get an x plus 4 that's going to cancel here and here. Now these x's on top do not cancel because they're both on top. But this 3 goes into itself 1 time and 15 5 times. And now I'm left with 5x squared and actually nothing on the bottom. And last but not least, we have x plus 3 over 2x minus 10 divided by x squared plus 5x plus 6 over x squared minus 3x minus 10. Now, there's 3 things that need to be factored here. So the x plus 3 is staying. Here we're going to pull 2 out and get x minus 5. I'm going to change this to times. The x squared minus 3x minus 10, I'm going to factor right away. I need 2 numbers to multiply to give me 10 that differ by 3. Well, that's 5 and 2. I want more negatives than positives. X squared plus 5x plus 6 is going to factor to 2, parentheses. I need 2 numbers that multiply to give me 6 that add up to 5. Well, that's 3 and 2, both positive. And now the fun begins. X minus 5 cancels. The x plus 3 cancels. The x plus 2 cancels. What am I left with? Well, on the top, I'm left with 1. On the bottom, I'm left with 2. And that's it. 1/2.